There were donuts out there, so I half expect like everyone to still be eating donuts.
Here, sugar coma.
Yeah. Okay. It is 3:40. I might wait like 30 more seconds just because I know donuts are delicious.
It's not fair to make you compete with that.
Yeah, no kidding. Put me up against donuts. Who's gonna want to come in here? All right, let's make sure we're on PowerPoint here. Make sure this thing's working. Okay. Glad I waited. Okay, it is 1 minute past. Let's go ahead and get started. So I am going to talk about scaling monorepos. And I'm very curious, I know it's a huge room. Who's in a monorepo right now? Who's like company is like, okay, well, some, good. So there's an interesting dichotomy between monorepos and multi-repos, and we'll talk about that. It's good to know there's already some here that are using. This is me. You can actually NPX, jcreamer898, that is a real thing. It's called Create My Card. It's Tierney from Microsoft Created. It's pretty sweet. So my name is Jonathan Creamer. I'm a senior engineer at Microsoft. You can basically find me on all the things at jcreamer898. I blog at jonathancreamer.com. And again, that's that cool NPX Twitter card thing. We love Disney. We're a huge Disney family. We grew up down there, and so this was actually just a few weeks ago we got to go. So really excited to be here. Last time I was at Connect.tech, I think like 2 years ago. It's one of my favorite conferences, and I just can't say enough good things about Pratik and Vincent and the fact that they were able to put this on again for us. So let's continue to give them fist bumps and say thanks to them, because this has been awesome. And keep coming back to Connect.tech. I think, honestly, I've spoken at a lot of conferences, and I think these guys are really some of the best in the business at it. All right, let's go ahead and dive in. So today we're going to talk about monorepos and how to scale them. But first of all, I want to get into why. Why would you want to do such a thing as this, to create this big monolith of a thing? But that's one thing I want to clarify with people, and I wrote a big blog about it, is that like monorepos are not monoliths. And I think a lot of people get scared off at the notion that like monorepo, monolith, they both start with mono, hence they must mean the same thing. It must mean tightly coupled components and all the nastiness of monorepos or monoliths. But let's see, I'm doing it myself. It's a similar word, but that's the actual opposite intention of a monorepo. A monorepo is intended to be this big code base, but decoupled from each other in scope, but allowing everybody to work as a group and see and be a part of a culture. So that's the first thing I like to clear up, is that a monolith is not a monorepo. That you can surely build a monolith that is not a monorepo, but they are not the same thing. So I like to clear that up. These are some of the hard things, I think, in a multi-repo setup. So there's these two competing structures for repository setups. There's a monorepo, and then there's the kind of the multi-repo setup. So Corey talked about style guides earlier, and when I was at Lonely Planet years ago, we had a style guide called Rizzo. And Rizzo was in its own repo, and it was really, really good component library. And it was built with Ruby and all the fun stuff and all kinds of cool things. It was actually featured on all kinds of, like it was like one of the top things you search for component style guides, and you found it. One of the hardest things that I had to do was, we had about 50 different Ruby apps that we had to try to bump that thing in. And trying to do that across 50 repos and keep Rizzo up to date was one of the most tedious and difficult things that I ever had to do. Because if you're talking about touching like a single line of CSS, you know, you had to go in Ruby bundle or gem bundle the thing and go gem update it and all the things. And even in a Node app today, it's the same kind of process, right? If you change a single line of code or you fix a bug in a huge company where you have many, many teams across your organization, you're having to track all these people down and make sure they've got the latest patches and the latest security updates. In a multi-repo setup, that's much more difficult than it is in a monorepo. We'll get to why later. I think integration testing is another area that trying to do that across multiple repositories requires a huge tooling investment that's really complicated. And sharing code has to be like in some sort of internal NPM registry or some kind of thing like that. So that's kind of really annoying. And coordinating changes and rollouts at scale in a multi-repo setup is actually also very difficult. And so some of the reasons, I'm going to quantify some of the reasons in my experience why I just love working in a monorepo. The first one is atomic changes. And what does that mean? That means that in one commit, I can make changes across the entire ecosystem of my application. So if I introduce some new component or some breaking change to a component, because it's in a monorepo and I can get the dependency graph of the entire monorepo, I'm able to make the change or fix a bug in a component and see it go propagate throughout the entire system. And I can make one git commit to fix all those problems at the same time. Or if I have my backend code and my front-end code together, I can change both the front-end and the back-end service at the same time. And that's a really cool thing. It gives you a nice, clean history of all the things you've changed in your repo. So as a team, if you're like, if a bug came up and you're trying to track it down, you can see the exact commits that the front-end and the back-end changed at the same time. It's also nice for docs. You can update the documentation for your entire code base along with the components themselves. So that's very nice. And it allows to have consistent build tooling across projects. That's, I think, another one of the more complicated things to deal with in a multi-repository setup is you somehow have to build this like consistent set of tools to use across multiple repositories. And then again, you're having to go track down all the teams across your entire company that are using your tooling and make sure they're up to date. And particularly in today's world, I mean, UA parser.js a few weeks ago and all these libraries that get hacked, you got to stay up to date on security updates and you got to get those guys patched and those teams ready to go. And so in a multi-repository setup, it's much more difficult to have that consistent build tooling. And it also fixes like context switching. You're not having to kind of bounce around different repositories. Again, it's easy to change across the entire platform. Another thing I really like is that our code reviews are centralized. So like we have one way to code review across all of the code base. And there's something really nice about that. Everyone's in the same place and you can set up rules that, you know, these 5 projects are owned by this team, and then you can set up branch policies that say anytime this code changes, I need these people to get reviews on it. So you get your centralized code reviews. It's even easier to stand up new projects. I mean, everybody here has probably tried to create a new GitHub repository to start some new project, and then you remember, oh crap, I gotta get Babel, then I gotta get Jest, and I gotta get all this stuff. And I mean, you can kind of solve that problem with some of the generators and all that stuff. But in a multi-repo setup, you just create a new folder and all the tooling is just there and it just works. And that's really, really nice. And it allows you to just iterate quickly. And the same thing goes for updating shared code, because you have these shared places in your monorepo that anybody can come and pull shared code from. I like to use the term blast radius testing because that's what I was talking about earlier. It's like if there's some component that I'm making an update to, I can see the blast radius of that change in my monorepo. If I make a quick CSS test or a quick CSS change that to me seems fairly insignificant, I can have a visual regression suite of tests across my monorepo that get that blast radius testing done. And we literally do this, by the way. We make a change and we have visual regression testing that runs the apps and takes screenshots and does diffing, and then I get a report back. And then I know immediately if I broke someone else's app. And then I can go track that team down and say, hey guys, like, I'm sorry, I'm about to break your app. Like, can you help me figure out what's wrong? That's something that's really nice to be able to do in a monorepo. Code discoverability obviously has another thing. If everybody's in the same place, you can see everybody's code and try to find other useful utilities that some other team might have. That's very nice. You can have a single continuous integration system for pull requests and releases. And I think there's a big cultural aspect of it as well. To me, when I was in a multi-repository setup at a bigger company, it just created these silos where like there was this team working over here on this set of tools and that team over there working on their set of tools. And as somebody who wants to to be a part of sharing and reusing people's code, like if they're built in different ways and they're constructed differently, it's just not as, it doesn't create this culture of sharing that I think working together in a monorepo helps foster. And it brings people together and helps create this entire culture around working in one ecosystem together. And it helps create processes to help the monorepo evolve and change. So, you know, if some team is finding difficulty in one set, they can suggest changes that the entire ecosystem that uses it can be a part of and make everyone's lives better. And that's what we want. So the one thing I want to highlight here, though, is that similar to what Corey said in his talk about style guide and component libraries, this thing doesn't work unless it's funded, because it's a lot of tooling. You have to have, I mean, really, when you get to this kind of scale, you have to do that anyways, though. That's kind of the point that I want to make today. It's like, if you get to the point where you have 50 or 100 repositories, 300s, hundreds of repositories, you're going to end up having to write all this different tooling anyways, and some team's going to have to manage that. And all these things that I've already mentioned become tremendously easier when all of it is in a single monorepo and you have one team dedicated, or many teams. Office's monorepo has many teams that are working together on certain parts of the monorepo, on the local developer experience, on the CI experience. And when that's all in a single place, it's just much easier to deal with. And in my slides, which I guess I didn't, but I'll tweet them later, I have some interesting articles from Google, Facebook, and Twitter. They're all three using monorepos and have been for a long time. So there's some good stuff going on there. So in any JavaScript ecosystem these days, there's a set of common shared tooling that I like to highlight that any monorepo, really any repo has, but these are the kinds of toolings that a tooling team will need to maintain in a monorepo. It's like your package manager, your task runner, your compiler, your test runner, your bundler, and your publish step. And at the last job I had at Eventbrite, I had always tried to figure out how there's like this thing in the front end world where the way you build code on your laptop or desktop mirrors what happens in production, and it's the job of this monorepo team to manage all this tooling. And I loved this terminology that Microsoft uses. It's called the inner versus the outer loop, and I made this Venn diagram of the JavaScript ecosystem version of that. So the inner loop is where the stuff that happens on your laptop, on localhost, and you've got things like your developer scripts, like running npm start, and version control scripts. But then there's this weird overlap with JavaScript to me that I've always had a hard time explaining to people that do more back-endy heavy things. Like, you're going to have to npm install both locally and in CI. You're going to have to run Webpack locally and in CI. You're going to have to do all these things in the middle, and it's just interesting to highlight that. And then there's things that happen only in the outer loop, which is your pipelines, your YAML, your Groovy files, your Jenkins files, all those things. Things like publishing to npm and security and localization. This is the kind of tooling that a good monorepo and a good monorepo team has to manage, has to work with on a day-to-day basis, so that at the end of the day, the feature teams can just ship code, because that's what we want. The team that I'm on at Microsoft is called 1JS, and our just mandate is to just let people ship code as often as they can, as quickly as they can, and this is the set of tools that we have to think about. In the JavaScript monorepo space, there's kind of like a framework versus tools sort of thing going on. You can have like an Angular or a React sort of thing. And so there's a lot of really good monorepo tools already in the ecosystem. Lerna, I think, was probably the most popular front-end monorepo project. And then the guy who created Lerna, Jamie Kyle, created Bolt, which is what I was using at Eventbrite. Rush is something that is another Microsoft-owned monorepo stack, but it's on a different team, owned by a different team inside Microsoft. NX is really good. That kind of spun out of Angular. And Turbo Repo is an up-and-coming one that I'm keeping my eyes on too, because I think that thing's going to be pretty awesome. And then these last three are proof that like these big monorepo companies like Google, Facebook, and Twitter have had to make their own things. And that's where the sort of pick your own adventure thing comes into play. And that's kind of where we're at on our 1JS team right now. But there's lots of ways you can kind of choose how you want to do things. Do you want to use Jar npm or PNPM? Do you want to use gulp or grunt? If you're still using grunt, yeah, grunt was like the best thing ever back then, man. God, so good. There's lots of things you can do. So that's kind of some of the reasons why I personally love working in a Monorepo and why I'm on a team that is doing nothing but supporting the engineers in our Monorepo. But I also am here to say it's not always rainbows and unicorns. There's a lot of difficult problems. And if you go Google with Bing, obviously since I work at Microsoft, for Monorepo problems, you'll find some of these things. So kind of some of the top problems that I have found and that most people find are working at a huge Monorepo are these things. Version control, particularly, working with Git at scale. Parallelizing your runner, your tasking, caching, hoisting, and versioning. So I'm going to kind of break down, in my experience, what we've dealt with and how we're fixing some of these problems. So obviously, in a Monorepo, particularly at like the Googles and Microsofts of the world, we have lots and lots and lots of code. And I mean lots, like literally billions of lines of code in some of these Monorepos. And so Git just was not really fundamentally ready to support that much code. So we've had to fix it. Git commands became really slow. It's super hard to navigate the project. You have slow clones. And Microsoft invested a lot of time into this tool, originally called Git Virtual File System, and now something called Scalar. And there's this really good blog post on what Scalar is there that I have linked. And Scalar has now actually been merged into Microsoft's fork of Git. And we have a fork of Git, yes, because we had to. And that's what we use mostly internally. But it's really actually, you can go, this is all open source stuff that you can go see. And you can actually use the Microsoft Git and get some of these benefits in the open source world. Some of the cool things that I like to highlight that the Scalar work now in Git can do, you can do a partial clone, which basically means you can clone the bare minimum of the repository and then specifically pull down Git objects that you need. You can also do background prefetching, which basically means Git is checking all the time for new stuff and pulling it down on demand or like as you need it rather than like on the first clone. Sparse checkout is probably one of the coolest things you can do now, and this is all Git native stuff. I think sparse checkout is actually even Git native now, but definitely in our Microsoft Git. Sparse checkout means if I'm a developer who only cares about 10 projects, you can actually get sparse checkout those 10 projects instead of having to check out the entire Monorepo, and that's amazing. That's very helpful. And all of this works by this cool file system monitor that eliminates the need for Git to scan your entire working tree all the time. That's kind of how fundamentally Scalar works. And then there's some other cool stuff with the commit graph, some indexing things. I copied some of that from the README. So my favorite ones are those first four, but it does even more. It's crazy how much it does. So we solved that problem. Git was not working, and we worked really hard, and we have got a solution for Git now. And that is Scalar, and now in the Microsoft Git fork. So really cool stuff. I highly recommend you checking it out. There's some great articles by Derek Stoley, who talks about all that stuff on the GitHub blog.
Do you do anything for your local Git? Like, did you do any optimizations on your actual code and your actual work history?
Yeah, I mean, you can. That stuff all works locally too. You can sparse checkout just on your machine and just only check out that stuff locally. Is that what you mean?
I mean more like you actually committed something huge.
Oh.
Your objects themselves.
There is, well, GitHub itself has some tools now for that. I forget off the top of my head what it. I mean, obviously you have to. That always means you have to rewrite history. So there's really no way around that still. But I'm trying to remember the Git rewrite thing. There is a thing. GitHub has a tool for that now as well. I'm trying to remember what it was, like a Python thing. Good question. Another hard problem that you have to overcome is dealing with parallelizing your tasks. Because when you're working with hundreds of packages, you need them to build. And there's a couple different ways you can go about doing that. First and most obvious and easy one is to use npm or yarn workspaces and use run, but that gets you to a certain place. Then you can step into using Lerna, and Lerna has a Lerna run task that's pretty good also and does a topological graph. But what we're using at Microsoft now is this tool called lage. And lage has this ability to create a task graph of your entire dependency tree and say, okay, so you've got these packages, these ones depend on this package, and it'll run them all in this topological order and make sure that if like package A has a dependency on B, then B gets built first and then A gets built. And Lerna can do that too. But what's interesting, and I'll show a picture of it on the next slide, is that we've built lage in such a way that you don't have to run like lage run build and then lage run test and then lage run this. You can actually run lage run build lint test, and it will create this graph, and it'll split it out across all the CPUs on your machine. And as soon as like the build tasks are all starting to get done, it'll automatically start moving to the next step, to the lint step or the test step. And it doesn't, you can do them all at once. And as soon as CPUs are available, it starts picking up the next task to run. And that's really nice, especially in CI, because you're harnessing the entire machine. We were able to start using some bigger Azure boxes with more CPUs and cut our build times down tremendously with this technology. So that's one thing you kind of have to do, as well as using something like a since flag in lage particularly. You can use a since flag, which basically gets a git diff of your project and converts it into package names. So you're like, I don't want to build the whole thing all the time. I only want to build what changed. And so that's really important for whatever task runner you're using to be able to do that. And so this is a picture of what I'm talking about, where you can kind of see over there. But basically, as soon as one task is done, the CPU will start picking up another task. And this is one also awesome feature of lage, by the way. It dumps out this profile that you can open in the Chrome developer tools, and each one of those lines represents a CPU, and it shows you exactly which task it ran on each CPU, and you can see the entire dependency graph get built. It's really awesome and super helpful for debugging. But even this has its limitations, because at some point or another, when you get to a certain scale, you've got to start distributing your stuff across computers, because one vertical scaling can only go so far. 64 CPUs, whew, that's a lot of processing. That's what we're at right now, but then you get to a certain point when you have to start distributing. And Microsoft has built a technology for us called BuildXL. And this is sort of similar to Bazel at Google, where it can do all this parallelism now. So now we can start taking that same lage dependency graph that we have and actually splitting it up across multiple machines in the cloud and doing all that work at scale and spinning it up on bazillions, literally, of machines that we have available and doing that work that way as well. So that's a really powerful thing that you'll get into as well. BuildXL works out of the box, and again, this is another open source tool that we have. It works with Lerna, with Yarn, with Rush, and that's through a thing called front ends, and these are all links you can check out. And it has incremental builds as well, because it does really, really aggressive caching. And it'll cache your file system state as well as previous builds. And it'll push all those caches to the cloud. And what's really amazing about that is, rather than having to like figure out what changed through git diff and like only build those things, BuildXL is so good that it just builds everything every time, no matter how big your repo is, but it pulls like 98% of it from Azure Blob Storage down in like just a matter of seconds, and only actually gives you the things in your PR or builds the things in your PR that have changed, but basically by leveraging distributed caching. And we'll talk about caching more in a minute as well. The other thing that both tools like BuildXL and Bazel do from Google is they guarantee input and output strictness through this term called sandboxing. And it basically makes sure that like package A can't reach into package B without strictly declaring its inputs and outputs and its dependency graph. And that's really very important in a huge monorepo to ensure that you have consistency in how things are being built. So definitely check out BuildXL as well. It's a really powerful open source tool that we have as well. The next really important thing is caching. That's what I just mentioned. So invariably, at some point, you're going to be doing just dozens of builds of all of these packages, and we've got 1,000 that we're dealing with right now, and probably thousands more that we're going to be adding to our monorepo. So it's really important to have a shared CI cache for your workers to be able to just pull things down off of. And so with Build Excel and actually with Lage, Lage also has caching built in. It will cache every step of the build graph for you in a Azure storage or wherever storage. When I say Azure, because that's obviously what we're using, but somewhere in a blob storage of choice. So that way, you're not repeating stuff in every CI build. I know at Eventbrite when I was there, I was constantly rebuilding stuff that I was like, I know I don't even need to rebuild this, but I have to because there's no way for me to figure out how to pull that from the cache. And a lot of this is built in to our task runner Lage through this tool called Backfill, another open source tool. And Backfill will literally, as soon as a Lage task is done, as soon as it runs a build script or a test script, it'll cache those results in Azure. And then if for some reason that PR fails, through a test failing or something, the next run of that will pull most of that work down off of the cache. So then I don't have to worry about rebuilding certain things that I know worked last time. That's really nice and makes CI much faster. And this premise to me is something that we're getting into now. We're not quite there, but if you imagine as a developer in the front-end code where you have a project on your local computer, and that project takes on lots of other dependencies that you don't necessarily want to build. You only care about your one package. What we're getting close to be doing with Build Excel is you can basically build one thing and then pull the rest off of that CI cache. Because since it's cache based on the file contents, you can just go grab those caches from the cloud and pull them down to your local machine. And then you're literally only building the one app or whatever it is you're working with. And you have then you have the cloud at your disposal to help your local builds work faster too. So not only are you getting the benefits of a faster CI, but you're also going to have this caching available in your local developer boxes so that you don't have to run Webpack 900,000 times a day. So that's a really nice advantage of this caching thing. So caching is huge in a big Monorepo. Gotta love caching. One of the other annoying problems with working particularly in a JavaScript Monorepo is dealing with nodes hoisting. So if you don't know what hoisting is in JavaScript, or in Node particularly, we'll talk about it here in just a second, but basically it's very annoying. And let's explain why. There's two major issues that hoisting can cause in a Monorepo out of the box. Phantom dependencies and doppelgangers, and these are documented on Rush's website. You can go check them out, but we'll talk about them right now. So with node module resolution, it's a default node behavior that when you are requiring React, that's really small, I think, but basically, if a package asks for React, what's going to happen is it's going to look at the closest node modules directory first, right? And then it's going to say, is React there? Maybe it is, maybe it isn't, but then it's going to go to the packages/node modules, then it's go to the node modules, and it'll recurse and do this all the way through your file system, looking around and around and around for React until it gets all the way to the slash. Okay, we kind of probably all knew that, but why is that a problem? Well, here's why it's a problem. Because in a Monorepo, if you have a packages directory where you have all these things living next to each other, if you have one package that takes a dependency on React, and another that doesn't, the default hoisting algorithm of NPM is going to hoist that package up to the Monorepo's root. And that means that if I have a package like this colors one that forgot to take a dependency on React, then the colors package can actually use React. And that could be really bad, because what if that colors package actually needed React 16.9 and 16.13 or 16.13 and React 16.9 got hosted? The colors package is going to break because it doesn't have hooks or some feature. Or similarly for Webpack, if they were depending on Webpack 5, but Webpack 4 got hoisted, then your build's going to fail. And so node module resolution will find a way to do that. And my slide thing, it just went crazy. There we go. It will find a way to find the right package. There are some, I think that was sort of a quick overview of both phantom dependencies and doppelgangers at the same time. The phantom one is like finding a package that wasn't there, and then the doppelganger one is like you think you're using the right version of React, but you're not. And both of those problems can cause huge issues in a build system where you're trying to build everything with Webpack. here's some solutions to that in a big monorepo. There's a really good NPM module called Connect.tech, and this thing uses what's called ASTs. And I don't know if you know what ASTs are, but that stands for abstract syntax trees. And that thing it's basically how Webpack works as well. It will literally read your code and break it down into tokens, and then allow you to manipulate that code. It's how Babel works, how Webpack works. And Connect.tech is really good because it will say, all right, this person imported React, but it's not in their package JSON. And so that's one pretty good way to catch it. But there's a lot of different kinds of packages, particularly we find with the TypeScript at types packages, where no one imports at types. You know, they're just sort of implicitly there by our build system. So those ones cause us real big headaches. Not to mention things like jest, which just, you know, or TS jest that just kind of are added in the tooling layer. And so there's no dependencies like in the package JSON necessarily on those, or in the code rather. So you can't just rely on scanning code for those. So that doesn't really work. What we have been working on, and this is really cool. When we first started off on 1JS, we were using Yarn, because Yarn's great, it really was. Anyway, it's fine, it's really good. But there were some performance issues that even we ran into with Yarn once it hit a certain mass. And we went in and created a fork of Yarn to go in and make some performance upgrades, particularly around network concurrency, because we were like sending so many requests at once to NPM, it was just dying. So we put some logic in there to fix some things. And then there was some just basic code things we went and fixed. And we're like, cool, we're gonna send all that back into Yarn. And this was right when Yarn v1 was getting into moving to Yarn v2. And Arcanus, who runs Yarn, was like, hey, we're not taking any more contributions to Yarn 1. And we're like, oh, well, that's good. So now we're stuck with the fork of Yarn. That's not good. But it's fine. We've been maintaining our own fork of Yarn. And this is actually on NPM. It's called Midgard Yarn. And it's much faster than regular Yarn because of some of the upgrades that we did. And it's available. Lots of teams inside Microsoft are using Midgard Yarn now, and anyone here could use Midgard Yarn. So that was sort of step one. That didn't solve the strictness problems that help with performance. The strictness things came because we were investigating tools like PNPM and Rush. And the idea of PNPM, if you've never heard of it, which I'll get to in a minute, fixes a lot of these problems. And so we took some of the work of Midgard Yarn and created this thing called Midgard Yarn Strict. And strict being the word here where we're saying you're going to have to declare your dependencies, you know, where you're going to break if you don't declare your dependencies. And also, if you've never used PNPM, it's this other, you know, another package manager-y thing. And not only does it solve some of these dependency hoisting issues I mentioned, but it also solves really, really good performance problems because what PNPM does in its install process is rather than creating this flat node modules folder at the root of your project and then, you know, having dozens of other node modules folders throughout your project and potentially duplicating multiple versions of React, because if you have two different versions of React required in your project, it's going to hoist one version to the top, and then all the rest of the Reacts that you have are going to be copied. So if you have like 10 projects that require React 16.9 and another 30 that require 16.13, the 16.9 one will go into the root of your project, but the rest of the 16.13 will be duplicated in your file system, causing massive bloat, which is why Yarn is so slow, right? Because it's like literally having to download and put React in like 50 different folders on in your project. And so what the install process of PNPM does is it actually has a store that it downloads everything into, and then it symlinks into the project. And so this is much, much, much faster, and on top of a lot of other things that it does. We weren't quite ready to go straight into using PNPM though for a handful of other reasons. So this guy Vincent, who I work with from our Oslo office, worked on Midgard Yarn Strict. And Midgard Yarn Strict creates this local store and does all this symlinking. And again, it takes away a lot of the duplication. It's much faster. And because of the fact that we put that store folder outside of the node modules directory, that hoisting model doesn't work anymore. So nobody can just accidentally grab a version of React because hoisting doesn't work anymore because we have installed those node modules in a separate directory, so you can't accidentally grab something you didn't mean to grab. This is where this gets even more awesome to me. So Vincent did all this work for 1.5 years, and I've been helping him implement it in our project, but we have actually been working together on an RFC to put this work directly into the NPM CLI in a new mode, a new opt-in installation mode called isolated mode. And we've been working with them to land those changes. And that is where I was like, that's cool. I'm really excited about that part because I'm getting to actually help contribute to make everyone's lives better, not just what I'm doing inside Microsoft on my One.js team. Like, we're going and making this better for the entire JavaScript ecosystem, which is like why I'm excited to be what I'm doing. Yes, thank you. And it's really fun. So here's just a couple of quick screenshots. I ran these a few minutes ago. Again, these are kind of small, I'm sorry, but basically in a small project I ran yarn with no cache in a minute. I ran Midgard yarn strict, that saved 44 seconds, or it went down to 46 seconds, but saved 15 just there. But the other cool thing that Midgard yarn strict and what we're working on for NPM is going to do is we found that with yarn, if you haven't taken a coding interview in a long time, you may not remember a lot of this, but there's this concept of linear ON time and logarithmic time complexities. And we were finding that yarn basically was growing, the install times of yarn were growing linearly with how big our Monorepo got, which is obviously like really bad because we have a lot of projects in there and we're adding more and more and more by the day. And so what we found after we implemented this PNPM-like strategy is that we've now gone sublinear with the way that we're able to scale in our Monorepo. So we could add thousands of more packages, but because of how this isolated mode and our Midgard yarn strict is working, it's gone flat. So basically the time of installing with yarn is not increasing linearly anymore, which is incredible. And was one of the biggest objectives we had for all of this work, because we're installing a lot of stuff. Node modules is a lot. And this is a screenshot of what it actually looks like on disk. So again, you've got this like node modules folder here with the .store, but then everything in your individual packages is symlinked back to that store. And so that's how the entire PNPM process works. And this is a screenshot here of the closed RFC. So this was about maybe a month ago, I think, that we got the RFC closed. And by the way, there is always every Wednesday a public NPM RFC meeting that anyone can join. And so I was on there a couple weeks ago helping Vincent with this. I can't take a ton of credit for I'm helping share the good works here. My friend Vincent here has done a lot of this work. I've been helping him implement it in our code base, but yeah, definitely give Vincent some thanks for that. So I'm really excited about that. Keep an eye on that project. There was a bunch of comments on that RFC thread, some really good examples of how it's going to help. I think of all the things that I've talked about today, this is the one I'm most proud of because your package manager is sort of fundamental to making the whole thing work for you in a Monorepo, at least in the JavaScript world. And usually that's the longest step of the process, both locally and in CI. And something I'm just now popping into my head that I realized I didn't mention is that Midgard yarn strict also will support installing subsets of your dependency tree as well. So part of the slow part in Monorepo is like running yarn when you first clone the thing down. It has to solve 150,000 node modules. But with the work we're doing, you're going to actually be able to say like yarn or Midgard yarn strict install and give it a package name, and it'll figure out that package's dependency graph and only install the dependencies of that thing. So if you combine that with like the ability to only get sparse checkout a certain project, you can imagine a world where you could get checkout like a few folders and then only npm install those few things. And so even though you're in a code base with literally millions of lines of code, you have no idea because all the tooling just works like you were only working on those 10 things. And that's kind of the stuff that we're working on here. So that's isolated mode. Really excited about isolated mode. Versioning is another one that's really difficult in a Monorepo. And our solution for that, there's lots of them out there. Semver obviously is the way we version things. There's two tools in particular that I want to call out that if you're trying to work in a monorepo and you're like, man, just trying to version all these packages is really difficult. Lerna obviously has it built in, but we're using something called beachball. There's also something called change sets. And what this lets you do is rather than, in a big monorepo having to worry about, you've got 1,000 packages and dependency trees, and I need to make a change to this package, so I got to go update the package JSON and go find everywhere else that's using that package and update their versions and then create change logs. These sets of tools will do that automatically. And they usually do that in the case of beachball. It basically writes a JSON file that describes like the git commit and what you're changing, and it puts those on disk. And then when you say beachball publish, it'll read all those change files and then go in and just read the dependency tree of all the things you're changing, update a bunch of package JSONs for you, and then you can generate some change logs and then move on with your life. And it's much easier than trying to hand do all that stuff. So check out beachball or change sets. Change sets is made by Atlassian. Beachball is another thing that we're helping maintain. So definitely take a look at those. A bonus problem that I wanted to make sure we brought up is ownership. Obviously, in a huge monorepo like this, you've got a lot of players in the game, and you don't realize how that is very complicated dealing with people and dealing with that many people. So it's really important, especially for my team designing and maintaining these tools, for us to build consensus and to try to help, like, again, around the pull request process. You have a way to say, these 10 packages are owned by this team and these 10 packages are owned by that team. That's huge. But I think, honestly, above all, the thing I'd say is just communicating is huge. Making sure that you're staying in contact with your developers and making sure that they're happy, and having that engineering system team to help maintain that stack. And we've actually been able to also put in place this really nice process where every change that I want to make to the monorepo, the first step I do is I go write an RFC for my own monorepo. And I put this process in place for myself, because what I wanted to do is have a dedicated way to change my monorepo, but make sure there was buy-in and visibility onto the process from everyone in there. So we have weekly RFC meetings where me and my friend Benjamin get together and we read the new RFCs, and we usually have about 20 or 30 people that come in and just make sure that everything seems good on their end and that the RFC looks good, and then we start to do work. And I also love that meeting because it's this culture of collaboration, and the entire ecosystem of our monorepo is getting to see the thing change and have an opinion and say, oh yeah, that's a great RFC. I actually had a similar idea. Have you thought about doing it like this? And then that helps me as the maintainer of this thing to make sure that I'm putting good effort into developing good requirements and making sure that everyone's getting all the goodness that they could possibly get. Because at the end of the day, my job every day at Microsoft is to make sure that everyone else's day goes really well. Because there's nothing worse than a bad developer experience as developers, all right? So, you don't want to wake up and hate what you have to do every day. So that's kind of what we do. So in conclusion, monorepos are very hard, but I think tooling makes them less hard. And that tooling is hard, but having a tooling team makes it less hard as well. And the cool thing is everything I've described is working in a monorepo of about 5 million lines of code. The Office one is even bigger than that, which is a whole different team. I'm managing the JavaScript one. But the thing is, if you go look around the JavaScript ecosystem, Babel is in a monorepo. There's lots of tooling in our ecosystem that are built in monorepos, and even if you only have 100 packages or even 50 packages, this tooling, some of the stuff, again, out of the box, like Lerna, Rush, NX, look into using those things. I think you'll be really surprised at how easy they are and how they can change your company's culture into this just nice place for everyone to work together in harmony. So yeah, definitely take a look at it. It's not something that, the hard parts come once you get into the hundreds of thousands and millions of lines of code. If you're at a company that's got you know, tens of thousands of code, just look into stuff like Learn and NX and give it a shot, and I think you'll really enjoy using it. The last thing I have to mention is a few, like last year or a year before that, I am a front-end developer. I've been doing front-end development for, you know, most of my life now, like 6 or 7 years. But in the last like 5, I took this weird shift out of writing React components like Corey does into like maintaining JavaScript tooling. And it was kind of fun because I was like talking to the JavaScript community, and I tweeted and I was like, what even am I? I call myself a front-end developer, but I never write JavaScript. I write like TypeScript to build scripts. I write Docker files. I write YAML. I work on CI systems. And so we sort of got together and I asked some people, and then we came up with this term called DevOps. So like DevOps instead of DevOps. It's very funny, but it's actually been really fun because these problems that I'm solving are some of them unsolved, or some of them are solved in different ways at different companies. And I want to come together as a community because this stuff is hard. And if you're interested in this kind of stuff, you know, go to that link or come talk to me, because I want to make the JavaScript ecosystem better, not only for the people I'm serving at Microsoft, but for everyone. Because, you know, every day something new is changing and there's a new way to do things. But if we keep doing this thing in silos, again, these silos that we've created, you know, Lyft is doing it this way, Facebook's doing it that way, Microsoft's doing it this way. If we all kind of just work together, I bet we can do some pretty cool stuff together. So that's kind of the spirit behind that community that I wanted to make sure I mentioned. But yeah, that's it. That's Monorepos. Thank you. Again, come up, ask questions. 898 on literally every social network that there is in existence, and so we can talk. Thanks. You can come up or whatever. Yeah, ask a question for them.
Yeah, a lot of interesting stuff. I'm curious though about use cases like having a whole lot of stuff in one repo. Like, I'm just having trouble picturing that. Like, is it all deployed together, or is this like different products?
Right. Yeah, that's a great question. So the premise of it is like there may be one big project in there. Like if you can imagine that one of the big clients that I'm supporting is like the Office Online suite. So like Word in your browser, and that's comprised of dozens of different teams, right? And so each one of those teams was in its own repo before, and it was really hard for them to communicate updates and get things, and especially trying to like do bundling and all these like upgrades and doing all these things. And so by coming together and being in one place, they've been able to coordinate that way better. So this works in that kind of a sense. So it works best, I think, when you have, you know, certain boundaries drawn up. But even if you don't, it doesn't matter because of the stuff that I've described here. It's like, you now, even if you're not a part of the big thing, even if you are just like a team that maybe only supports 5 folders out of the 10,000 Monorepo folders, you still get all the other tooling benefits of being in there. And because of the way they're building this stuff, even if you only own 5 things, it's not going to slow you down because we've built all this other stuff around it. So it really helps when you are on a team where you're, you know, a part of this big application or whatever. But you still get the benefits of being in the Monorepo. You don't have to worry about, you know, you can imagine a company our size who's got to do all this security checking, component governance, and all these crazy things. And by coming into the Monorepo, you just get that out of the box. You don't have to worry about any of that stuff. Because again, at the end of the day, the goal is just to let the teams who are shipping code to customers do that as quickly and efficiently as they can, because that's what matters anyway. So that's kind of the main benefit, I think.
I don't know if you're going to be willing to share this with us. It's kind of trivia, but it's always interesting to know how the teams work. How long does a build take? And what is the reasonable time? What is your target for getting a whole build out?
Yeah, so the Office Monorepo is different, but our PRs take anywhere from 40 minutes to maybe an hour. In one of our tenants, the other tenant takes a lot longer because they're doing blocking visual regression testing as well. So that one I think takes like 3 hours, but that one's debatable whether or not we're trying to get that one down to about 40 as well. And actually our goal, and part of our goal in the next few quarters, is to get it down to under 30 minutes. And that's what we're going to be investing in, like tools like ESBuild or whatever, Webpack Module Federation and all those different things to get that down even faster. And in the stuff I was talking about with NPM isolated mode, where you'll be able to install all your packages really quickly as well. So all of that's coming as well. A lot of this is new for me and for us, I mean, literally in the last year and a half. So I'd say 45 minutes is a good place to start. And we're only going to get faster from there, even inside of this ginormous monorepo. And the caching and all that stuff is where that helps. So good question. Anyone else? Yeah, sweet. Enjoy the rest of the conference. Come talk. I love JavaScript tooling.